Okay, all right, so yeah, we're trying to find the acceleration and tension of the rope, right? So for this question, actually, something to be aware of is that first of all, we got to know the direction of acceleration of this system, and that the direction is going this way, right? Because 12 kilograms is heavier, so then of course, just by common knowledge, it's gonna be going that way, right? So then the thing about setting up this problem is that you gotta set the direction of acceleration to be positive, actually, okay? Which is different than just setting an upward direction as positive or downward direction as positive, because when you're talking about up and down, it goes both ways, right? It goes for the 12 kilograms and then it goes for the 10 kilograms. So then it's really hard to say positive and negative because you have two masses here, okay? So actually setting the direction of the acceleration to be positive, that's actually the safest option, because now the entire system follows one acceleration, right? So then you'll have one direction to follow, right? Which is better than having upward as positive, because when you're going upward for the 10 kilogram, you're going downward for 12 kilogram, right? So how do you talk about that, right? So having the direction of acceleration to be positive is actually good. Okay, so then with that being said, okay, something that we have to do is that we can talk about the two masses, okay? So for the two masses, they have their own net force, okay? So you can actually write it out, but I'm gonna say F net 1 for mass 1, right? F net 1 is equal to m1 times the acceleration of the entire system, but that is equal to, right? If you're talking about the mass 1 is this guy, right? Let's set the 12 kilogram to be mass 1, the 10 kilogram to be mass 2. But then the thing is, now if you want to figure out the net force on the first mass, it'll be actually good if you draw like a free body diagram for both of these masses. So let's do that, right? Okay, so free body diagram on the mass 1. We know that mass 1 is, right, it's pulling down, right, because that's the heavier mass. So then force of tension is like right here, and then you want to have the force of gravity just to be a bit longer than that, right? So I think that, no problem. And then when you draw the mass 2, the diagram for mass 2, notice that mass 2 should be slightly smaller. I mean, it doesn't have to, right? But just on picture, it looks a bit more clear, right? Force of tension should be the same, right? Because they're attached to the same rope, so force of tension should be the same, right? So when you're drawing them out, make sure that they're the same length, okay? Or about the same length, right? And then force of gravity for mass 2 should be slightly shorter, actually, compared to the force of tension, because for mass 2 is going up, right? So Fg2 should be slightly shorter, okay? So that's the free body diagram for both of these. Now, if you go back to talking about mass 1, the net force of that, right? Because we know that mass 1 is going down, right? But that's going in the direction of the acceleration. So then when you want to write that out, right, you want to put actually Fg at the front. So Fg1 minus the force of tension. That's equal to, right, m1a. Because I want, right, I know that the net force on mass 1, it's also going in the same direction as the acceleration. Okay, I'm going to repeat that, right? The net force on mass 1, that's also going in the same direction as the acceleration, okay? So then when you write it out, you want to put Fg1 at the front, not T at the front actually, right? Because in order to make it positive, you want to put the bigger force at the front, right? Because F net 1 is going in the same direction as the acceleration. So F net 1 is positive. That's why you put FG1 at the front, actually, instead of T at the front, okay? Now, you do the same thing for mass 2. Okay, so we're just going to write everything out. F net 2, mass 2, A, right? And then same things. But then this time, right, again, if you talk about the net force on mass 2, just know that mass 2 is also going in the same direction as the acceleration, right? So then the net force on mass 2, it's also going in the same direction as the acceleration. Otherwise, it wouldn't turn that way, right? So F net 2 is also positive, okay? Then if you want F net 2 to be positive, you put the bigger force at the front. On mass 2, the bigger force is the force of tension because it's pulling it in the same direction as the acceleration, right? So tension force needs to be at the front for this guy, right? And then subtract Fg2 because Fg2 is going in the opposite direction as force of tension. So you take it out, right, by subtracting. And then just write M2A on the other side, okay? So that's for mass 1 and mass 2, okay? But now we can write the same thing, but now we go for the entire system, okay? Because now you have the net force on mass 1 and mass 2. You can describe the whole system now because the whole system is made up of mass 1 and mass 2, right? Then if you want to describe the entire system's net force, we're going to use Newton's second law again, right? But then this time, when you're describing the net force on the entire system, it should be big M, right? Because the entire system has two masses. So then it's good to look at these two masses both at the same time, right? So use big M. And if you don't know what big M is equal to, right, that's the total of the two masses that we have, right? Because it's the entire system. So you got to use all the masses, right? So mass 1 plus mass 2. A is the same, right? Because the entire system follows the same acceleration throughout. So you shouldn't change A, okay? Okay, now we have that. But you can rewrite the F net, the total F net, as this. Plus that, right? Okay. Now you might ask, right? Why don't I subtract? Or do I write addition all the time? Or sometimes do I subtract? Like, how do I do that? Or how do I determine if I write plus or minus, right? So then in this case, we write plus, not because it's plus all the time, okay? It's plus because we know that F net 2 and F net 1, they're in the same direction, right? If you think about the system, F net 1 is going down, right? Because it's the net force on the mass 1 is pulling it down. And then F net 2, right? It's the net force on mass 2 is pulling it up, right? But then they're going in the same direction, right? So then in this case, that's why you add them up, right? Because they go in the same direction. If they're going in the opposite direction, then you have to subtract them, okay? So it depends on the situation, right? So this time, right, you have to actually think about how the system works and then put the forces together, right? So we add them together, and now we can substitute. F net 1, I have it written out on the top for mass 1, so we're going to plug that in, right? Fg1 minus T, that's F net 1, right? Plus F net 2, it's also on the top, right? It's T minus Fg2. And then that is equal to MA, right? Okay, F net 1 is this guy, F net 2 is this guy, right? So we just substitute. And now, right, we're going to rewrite everything in terms of little m1 and little m2, right? So fg1 is m1g minus, well, actually the t's cancel out, so we don't need to write that anymore, right? So it will be just, right, in this case, it will be just m1g minus m2g. And then for the other side, big M, I can rewrite that as m1 plus m2, right? And then keep the acceleration, right? Okay, and then isolate for A. So A is equal to this guy minus this guy over this. You can factor out the G if you want to, right? So for cleanness, let's do that, right? Oh, should be minus on the top, sorry. And then that on the bottom. Okay, and then after that, just plug in all the numbers, right? So now it's like 12 minus 10, and then 9.8, and then 12 plus 10, right? So now you would have 0.89 meters per second square. Now, if you want to write the direction of the acceleration, right, you can't say up or down, right, because it goes for two masses, right? Up for mass 2 is down for mass 1, right? So up and down is not good. So then you can say left if you want to, but then you can also say, now that I think about it, you can also say counterclockwise, right? Because it's kind of like the whole system is rotating, right? So you can also say counterclockwise, but yeah, if you prefer to write a shorter word, then left is also okay, right? So yeah, counterclockwise, okay. And that's the acceleration figured out, okay? So then to talk about this, right? To note that, right, you don't, so something to be careful about is that you don't write T minus FG1 all the time, right? Because in this case, right, if you want to talk about the net force on mass 1, right, net force on mass 1, again, I know that I'm repeating, but net force on mass 1 is going in the same direction as the acceleration, right? Because it's, right, it's pulling that way, right? So then net force on mass 1 is positive. If it is positive, you have to put the bigger force at the front. The bigger force is Fg1, right? So that's why Fg1 goes at the front, okay? For the second mass, again, right, net force on mass 2 is going in the same direction as the acceleration as well. So then it's positive as well. For it to be positive, you have to put T at the front because force of tension on mass 2 is bigger, right? So that's how you determine which guy goes at the front, right? Not T minus FG1 or FG2 all the time, right? It depends on the situation, okay? So so this one we have to really think, right? So sorry about it, right? I didn't catch that in the beginning when we were in class, but yeah, that's how this goes. And it's going to make a difference because later on, now when you calculate for the force of tension, right, it won't be different if you go for two masses. Because back then, what we did was that if you put T at the front, you see that it's turned around, right? So the values are bound to be different, right? But then that's not the case, right? Actually, Fg1 is supposed to be at the front, right? So then when you calculate it like this, right, it's going to be okay this time, right? Okay, so now, right, if you want, you can actually isolate for T using any of the equation as you like, right? We're going to choose the second one because it's easier, but if you want to go for the first one, you can, right? Which is negative T is equal to M1A minus Fg1, and then just multiply by -1 both sides. And now you're going to get this, right, plus this, right? Because when you multiply by -1 both sides, you multiply -1 to everything, right? So that means -1 to this. Oh, sorry. That means -1 to this, right? And then also -1 to this, right? So that's how that goes. Okay, and then after that, you just plug in the numbers, right, at the very bottom. So then we're gonna use. I mean, you can use both, right? So actually, why don't we use both to verify, right, that we're on the right track? So I'm gonna put it here, okay? And then, yeah, we're gonna use the first equation first, right? So then let's do that. Plug in the numbers. So t is equal to -12. A is 0.89, right? So that, and then plus m1, well, m1 is 12 again, right? Times 9.8. And then if you plug it into the calculator, you're gonna find that this is, well, let's see, right? Negative that plus 12 times 9.8. Yeah, so that's 106.92. If you put it in 3 sigdics, that is 110, right? So that's tension 1, right? Actually, I think, no, 2 sigdics, no. Yeah, it's 2 sigdics because the least number of sigdics is 2 sigdics in this case. Yeah, so 110 newtons, right? And then for here, right, if you try it with equation number 2, right, using the second mass, you're going to realize that it gives the same thing, right? So, yeah, that plus, and then Fg2 is, yeah, you use 10 kilograms times 9.8, right? And then now it's, yeah, if you plug everything into the calculator, it's, well, that's 8.9 plus 98, right? Which is the same thing, right? 106, right? 0.9, and then if you put it into 2 sigdics, is 110 newtons as well, right? So the problem that caused the force of tension to be different is actually the way that we set it up in the beginning, right? Fg1 is supposed to be at the front in this case, right? Because the situation, okay, I know that I'm repeating it a lot of times, but yeah, one last time, right? Fnet1 is positive because Fnet1 is going in the same direction as the acceleration, right? So then for that to happen, you got to put the bigger force at the front, and on mass 1, the bigger force is the gravitational force, which is Fg1. So you put that at the front, right? Not T at the front. So that's how it goes, okay? So yeah, later on when you do other questions, so you know, this one right here, okay, this one right here. So yeah, do remember that when you set up the force, it has to be depending on the situation, right? In this case, mass 2 is bigger, but then doesn't matter because the net force on mass 2 is going in the same direction as the acceleration. So when you set it up, make sure to set it up properly. Okay. All right. So that's this. If you got any questions, be sure to email me, right? I'll be glad to answer if I see it. But other than that, good luck studying, and then I'll see you next year. Okay. All right. Then bye.